Hi, this is Monik, and
This is Dia.
so today we are going to discuss a paper which is about the tool called CNN Explainer. And the purpose of the tool is to make CNN learning easy and visually interactive. So this is how the explainer looks like, and Dia would be showing you the demo of the explainer later in the presentation. So the basic agenda of the paper is first we'll go through the explainer overview, and then we'll tell you why we need an explainer. We'll tell you the background for the CNN and how to use the explainer, and then we'll conclude it. So as the name of the paper suggests, the paper is primarily focused on explaining the functioning of the tool, the explainer, and what are the challenges faced by data science practitioners to understand powerful deep learning models, and how those challenges are resolved by the tool. And we also talk about the design interface of the explainer. Oh, can you change the slide? Yeah, I'm unable to do it. Thank you. So a survey was conducted, 19 students and 4 instructors, and they were asked the question that what were the biggest challenges they have faced while studying CNNs, and what will be the most helpful features if there was a visualization tool for explaining CNNs to beginners. So based on the key findings from the survey, these were the challenges. So the first one was complex model structure. So it was found that people generally find it difficult to understand the complex CNN model structure because it's composed of different layers, and it's difficult for them to understand the connection between those layers. Another one was complex layer operations. So it's also difficult for them to understand the complex mathematical operations behind those layers. Another challenge was that it was difficult for them to understand the connection between low-level mathematical operations and high-level model structure. It was not easy for them to mentally visualize the geometric transformations behind the model. Another one was to design an effective visualization tool which can clearly explain the mapping between the algorithm and the visual encoding, and which can engage the learners. And the last one was that usually neural networks written in deep learning frameworks require powerful hardware with GPUs. So another challenge was to develop a learner tool that can make it accessible for everyone without using such resources. So based on the challenges, these were the goals set for the CNN explainer tool. So to tackle with the first challenge, the aim was to create a visual summary of a CNN model. So it can visualize all their outputs and connections in one view, which could help users to visually track how input image data are transformed to final class predictions through a series of layer operations. To tackle the second challenge, the goal was to design an interactive and visually attractive interface so that it will be easy for them to understand the mathematical computations and the inner working of the layers. For the third one, the goal was to design a tool which enables user to navigate between different levels of the CNN, and so that they get the entire background of how the CNN actually works. And to tackle with the fourth problem, the idea was to design an visualization system that's easy to understand and that can engage users by better animations of the model. And for the last one, the idea was to uh, create a tool that is easily accessible by the users by using modern web browsers as a platform to explain working of the CNN. Uh, and now Dia will be showing you the demo of the explainer.
Thanks, Monik. So before we get into the jump right into the tool, so I would like, Monik, can you just mute your, sorry, but can you mute your microphone, because I'm hearing my voice twice and it's distracting me.
Okay, just a minute.
Okay, so before jumping into the tool, I would like to give a high-level overview of CNN in context of image classification. because that will help us in understand and make sense of the tool and how to use it. So first of all, we have here a tiny VGG model. So these models usually, the CNN models always have in each layer a convolution layer in each step. Then each of these convolution layers is followed with an activation layer or activation function. And then we have optional max pooling or average pooling layer in general. And in the last, in the end of the CNN part, there is a flatten layer, and this flattened layer enrolls that n-dimensional matrix into one-dimensional vector. So that makes it connected with a fully connected neural network in order to make classifications. So the convolutional layer basically consists of filters, and each filter extract information from image and features. For example, in this image, we have this filter, which is focusing on extracting the light gray color. So that's why in the heat map image, the light gray color is activated. The output dimension of the previous of one layer equal to the number of filters. For example, if we have 10 filters, the next layer will have 10 channels, and the convolution layer have hyperparameters like filter size and padding size and stride size. These values should be set by the neural network designer. So yeah, and the filters values are trainable. So the filter values are trainable using packet propagation. So for the value for the center for the filter itself shouldn't be set by the designer. Yeah, and each filter detects a small pattern. The smaller the filter is, the more concise it is in detecting more details from the image. And now for the padding, this is all all information are probably you all are familiar with, but it's just a refresher. So for the padding, so this padding have two purposes. The first one is to prevent the image from shrinking. So when we, especially when we have a very deep neural network, the second purpose of it is to prevent throwing away information from the image edges. For example, here in this pixel, the center pixels get convolved more times than the edge pixels. So we add padding so we don't throw information over the edge pixels. And yeah, so some common pads are the valid and the same. So the valid padding type basically means there's no padding, and for the same padding type, make sure that the output size is equal to the input size. In frameworks like Keras and TensorFlow, when you choose the same type padding, it automatically finds the stride value and the padding value that gives you the same output dimension. And after the convolution layer, we have the activation function. So the most common two activations are the ReLU and the softmax. So the ReLU activation is non-linear, and it captures non-linearity on the image or on the matrix, so it can draw non-linear decision boundaries. And there's some other activation functions like sigmoid and tanh, which are also non-linear, but ReLU proved that it most times it works better than tanh and sigmoid, so it's almost always used with the CNNs. Same thing for the softmax. So the softmax makes sure that it outputs a probability for each class, and all these probabilities sum into one. And we have the optional pooling layer, which can come after the activation function. For the pooling layer, we have many different types of pooling layer, like max pooling, average pooling, and global pooling. And the purpose of the pooling layer is to decrease the spatial extent, which means that we will have less number of parameters, and this will make it quicker in training. And also it will make it less likely to overfit because we have less parameters. And for the pooling layer, we have also a kernel or filter, and it is a hyperparameter, so we should choose these values for these hyperparameters. And yeah, finally, if we have the flattened layers, and these flattened layers unroll n-dimensional tensor into one-dimensional vector, so we can connect it with the fully connected layer to make predictions. So now let's jump into the tool and show how it works. Okay, so basically the tool integrates three main views. The first one is the overview, which is the opening view of the CNN explainer. This opening view shows the connection between the neurons and the previous layers. So hovering over one of these neurons can show us the connection. So yeah, this represents a high level of the overall structure of the CNN. And as we said, this is a tiny VGG neural network. So yeah, each layer is represented as a heat map. And for the second view, we have is the elastic explanation view. So we can get into the view by clicking on one of these kernels or neurons. So this can interactively show the process of the sliding kernel. Yeah, so we can also click on this component, and it will open in a bigger size, and we can view the kernel values and how they are changing. Yeah, and we can also hover over here and on this kernel icon, and we can see the kernel values appears on the top. Yeah, and we also have a second type for the elastic explanation view, which is the flattened elastic explanation view. And this view explains how we get this output. For example, if we click on this class, it takes us into this view. So yeah, this view shows us how we map every two-dimensional matrix into a flattened vector. So each pixel corresponds to one neuron on the flattened layer, or yeah, the one-dimensional vector. The same thing with these other neurons. And we have the third type of view, which is the interactive formula view. And this can show us the mathematical components, so we can bridge the gap between these convolutional operations and the mathematical operation, and we can view this by clicking on the softmax from here, and it shows us the formula of softmax. So when we hover over the number over one of these number, it highlights the logic circles. So for example, this number corresponds to grid banda class. So yeah, and the dark numbers mean higher probability, and we have this class which is the highest probability, which corresponds to espresso class, which is the current image we are choosing. And we can do the same thing with the ReLO activation and max pooling layers. For example, here we can click on the reload activation, and it can show us how this operation is happening. For example, here we have some negative values, and we can see that that it's mapped into 0. Same thing for the pooling layer. We can see that every 4x4 kernel, we are taking the maximum value for every 4x4 kernel. We also can upload image from our site. For example, I want to upload this pizza image. Gonna copy this link. And yeah, now we can experiment with our own image and see how we got this result. And we have another mini tools under that main tool, and this one shows us how the kernel, whether it is for the max pooling or for the convolution layer. So we can here choose the input size and see how can this make changes. For example, when we have here input size of 6 and pairing of 1, we have the same output size when we have a pairing of 1 and the stride of 1. If we increase the stride and test that, we can, yeah, stride of 2 is not allowed. So let's change the pairing. Okay. Yeah. Now we can see experiment with different values and see the output. So this 6x6 matrix correspond to this pixel on the results. So yeah, that's it for the tool. I encourage everyone to check it after this presentation. It is very educative. I'll just go back to the slides. Okay. Okay, now I'm leaving you with Monique to explain some results and studies and the conclusion. Go ahead, Monique.
Thank you, dear. So you saw that if you're a beginner, it will be easy for you to understand CNNs if you use this tool. So a study was conducted with 16 participants who had no knowledge of CNNs or very little knowledge of CNNs. So the basic idea was to know that how much could they learn. So after completing the learning process, participants then self-reported their score on their knowledge of CNNs. So the main idea was to get an idea on what extent they could learn. So the results were as follows. Yeah, so these numbers here show the average rating for usability evaluation and usefulness of feature according to the participants. So the range was from 1 to 7, and you can see almost everything is above 6. Only easy to understand is below 6, and that too is 5.9. So from these high ratings, you can see that it was really easy to use and understand for the participants to use the tool. They retained a high engagement level during the session and eventually gained a better understanding of the CNNs using this tool. And for the future work, there were some ideas. The first one was to expand additional features to learn about the training process so that we can include cross-validation and back propagation in it. The other one was to generalize it to other neural networks such as LSTMs and other transform models, not just CNNs. And another one was to incorporate advanced algorithm visualization, so to enhance the visualization process of the tool. And the last one was to expand the observational studies, like we can have a before and after quiz so that we can understand better that and compare the benefits of the tool with the participants. Yeah, so that's it with the paper. Any questions?
Hi, great presentation, guys. Did you see if they offer any other models on the applet to choose from besides VGG?
Yeah, so no, I think that one of the limitation of the tool that you can't choose a different model, and also you can't change the kernel size and the stride and these other hyperparameters. So at this point, it is static.
Gotcha. Thanks.
Any other questions?
Hi, this is Shivendra. So my only basic question is like, what are the main implementation of CNN? Which are the main applications where CNN is vastly used or widely used? Is it for computer visions and specific applications, or like there are other applications as well?
So your question is what is the first what was the first CNN was used for?
No. My question was like, what is the main implementation? Which applications it is widely used currently? Is it like used for image recognition software like computer vision, autonomous driving kind of examples, or are there any other applications for CNN?
So for the CNN, for the convolution neural networks, it can be used actually with also with text. So it's not just for images. It is widely used with computer vision and its application like autonomous system and stuff. So yeah, and there's many famous structure for the CNN implementation, like ResNet. Um, and if you are also asking about what was the first CNN layer, or I mean CNN model, I think it was LeNet.
Okay.
It was designed in the 19s. So I'm not sure about it though.
Okay. Thank you so much.
Sure.
I also have a question. Can you hear me?
Yeah, we
Yes.
can hear.
Okay. By the way, great presentation. Thank you very much. I'm just curious. Let's say if I write a simple convolutional neural network, can I simply use this tool to understand what's happening in the neural network? Maybe I didn't catch the part. For example, can it take my model, pre-trained model, and visualize?
No, so that's not possible with this tool.
Okay,
Yeah.
It's not a dynamic thing then. There's only a VGG example there, right?
Yeah, exactly. Okay. So it's not dynamic at all. And you have to go with the same kernel size and stuff. So yeah.
Okay,
That can also be one of the future works, future points.
Sure. For example, in my case, I would like to see how an encoder-decoder network works. For example, for me, it's easy to understand a vanilla network or maybe a convolutional neural network. But for example, a decoder, which is a difficult architecture. So I would like to see that, but maybe in the future it might be possible. Thank you very much.
Thank you.
So any other questions? Okay, I think the presentation ends here. Thank you everyone for listening.
Thank
Goodbye.
you.
Last question, like, could you share the like this? Is it public? Like, can we see it online? The tool which you used for the presentation?
Yeah, it's public. It's the link is in the paper. We'll share it.
Yeah, it's public. Yeah, just 1 minute. I shared the link. It's on the chat.
Thank you so much.
Welcome. Okay, thanks everyone. Thank you for listening.
Guys, yeah, thank you. Thank you for the presentation.
Thank you.
Thank you.
Thank you, everyone.
Thank you very much.
Have a good day.